Good morning, everyone. We still got people logging in here. I see the number of participants increasing. So welcome, everyone. Glad that all of you are tuning in this morning to cover one of our fairly common topics we'd like to talk about and people apparently like to hear about, since, again, this is one of our higher attended sessions. A little more of a back to basics today, but something that we love to talk about. We love to help engineers and contractors figure out joint layout, since it's kind of unique and kind of a challenge for us. So welcome, everyone, to our winter webinar series. Those of you tuning in for the first time, we're glad to have you here. Those of you that have seen a lot of these, you've seen this title slide a few times. These are our sponsor companies for the winter webinars that we're doing this year to replace our in-person conference. So Superior Materials, Levy Company, and St. Mary's Cement. Very happy to have these companies sponsor this and help offset the costs of our Zoom software license. So we appreciate that, and it's brought to you by those companies today. We've got about an hour topic, probably go a little bit longer perhaps if we've got a lot of Q&A. And please use the Q&A button on your Zoom software panel there to send us a question. If possible, whoever is one of us, Heather or myself, who's not speaking, will maybe type an answer or butt in and address it maybe aloud or ask the other person. So please use that as much as possible. The chat window's okay as well. It's a little easier for us to see the Q&A versus the chat window, but if you do have just a quick comment, the chat window works okay as well. Everyone who is logged in this morning as a participant with a unique email address will receive a professional development hour or continuing education hour credit for your time this morning. And we will email those out later, either today or tomorrow, hopefully by then at the latest. So we will see. So we've got two MCA staff, Heather and myself. You see us on the video there. First, Heather's going to start, and she's been with us for almost 8 years now.
It's almost 8 years, Steve.
Yep, that's awesome. It's flown by, but it's been great. She was with the Barry County Road Commission for 10 years prior to that, so she's got county road experience, road and bridge construction projects. Her job with us is to help promote concrete, like we all would love to see be used, and works primarily with our producer members, but any of our MCA members that have issues, need assistance, have questions, primarily in the private markets, so non-public works for the most part. But she also has been managing our social media presence and marketing plan that we've really increased in the last year or so. She has a bachelor's in civil engineering from Michigan State, so go green. And we're going to kick it off.
I'll introduce you, Steve.
All right.
So, and then Steve Waalkes, our PE, he's been with the MCA for 15 years, so way longer than me, Steve. Prior to that, he was with the American Company for 6 years. He provides technical assistance to our members, engineers, architects, and owners, or anything else concrete related. And again, he, like me, works in the west side of the state, promoting the use of concrete through our design assistance programs, presentations, troubleshooting, etc. He's got a Bachelor of Science from Calvin University and a master's from the University of Texas at Austin. He's active with ACI, ASCE, MSPE, and other local nonprofit boards. So we get to present together today. So with that, I guess we'll get started, right, Steve? Okay, let me share my screen and we'll get going. Okay, well, we are talking about joint layout for roads, parking lots, and roundabouts.
Heather, we're seeing the non-show version.
Oh, well, that's dumb. Let me figure that out. Sorry about that. Let's go to this one. Okay, are you seeing the right one now?
That works, thanks.
Okay, I'm sorry, everybody, that's on my other screen. So if I'm looking over there, don't think that I'm looking all over the place. Okay, so joint layout for roads, parking lots, and roundabouts. We'll get right into it here. What is the purpose of joints in concrete pavement? The reason we put joints in concrete pavements is to control the natural and transverse and longitudinal cracking from the internal slab stresses. We divide the pavement into construction lanes or increments, and jointing needs to perform the following. It needs to accommodate for the slab movement, provide load transfer, and provide a uniform sealant reservoir for those pavements that we're going to be sealing. Basically, if we didn't have joints, concrete would crack on its own and it might look kind of yucky. So we really want to make sure, this picture kind of illustrates it here. Concrete, again, left to its own devices is going to crack. So we've been able to develop patterns to help control those jointing or be able to control the cracking in our concrete pavements and make it look a little bit more aesthetic. So with natural crack development, it all depends on your temperature gradients, the moisture gradients, the thermal cycles of the environment, and loading. Cracking usually occurs sometimes after 12 hours, but it may take months to actually see the cracks. What we want to do is joint our concrete pavements to control and give relief areas and actually help those cracks to go up into a more aesthetically pleasing pattern. So we provide a series of saws or joints spaced strategically to control crack formation. Steel mesh, Steve and I get on this quite a bit when we are presenting. Steel mesh is not a structural element. It holds cracks together after the cracks are formed. And we're talking about the rusted wire, welded wire mesh. We're not talking about structural concrete or structural rebar here. We're talking about the rusted stuff that typically ends up at the bottom of the slab. It holds cracks together after the cracks form. It needs to be cut or stopped at joints because it can lock up the joints. And it's not really recommended to be used in Michigan. We still see a lot of it being used, but again, typically it ends up on the bottom. It's not in the middle of the slab. Those rusts, that wire mesh can actually be a conduit for water to get into your slab and crack it as well. So there's other alternatives than using this mesh. The fiber mesh is a great, a great alternative to this. It usually costs a lot less. So this is maintenance intensive. It doesn't really do what we want it to do. It might hold the cracks together for a little while, but then, eventually it's going to rust through and those cracks are going to be areas where water can get into your pavement. So that's my soapbox for steel mesh. If you want to talk about it later, we will can have a whole discussion about it. So there's three types of joints that we talk about. There's isolation and expansion joints, which those are the joints between slabs or at structures. Where we are going to saw cut or tool joints in, and then contraction joints, where we saw cut or tool them in. And then there's construction joints, which are the edge of pours or the form lines. So those are the three different references of joints that we talk about. So isolation and expansion joints, we typically use between maybe a new slab and an old slab. We want to use those isolation and expansion joints in areas where the concrete may be changing or where we have structures. Really, that isolation expansion kind of explains it all. It's where we want to isolate an existing slab or structure from the new concrete. So as you can see in the first photo here, they isolated this new pavement from this existing curb and jointed right to the edge of this, and it looks pretty good. Over here, they did not do it. So we have new pavement, old pavement, and what happened was this old pavement actually cracked the new pavement here. So just kind of an example of what an isolation or expansion joint would look like. Transverse contraction joint, this is a textbook contraction joint. We saw cut it and it cracked right where we saw cut it. That's exactly what we want to see. Now, transverse contraction joints, conventional saw depth if you're going to use a conventional saw, is the thickness divided by 4 is the minimum depth you should be for your joint. For early entry saws, minimum of 1 inch deep, depending on pavement thickness. I know this does vary with some of the saws that we use, so this is just kind of a basic rule of thumb, but want to make sure that you work with your manufacturers if they are recommending something different for those early entry saws. With that, we'll keep going here. So sawing, preparation. We want to develop a plan for our joint locations prior to placement. Too often we're out on a job site and people or contractors, the engineers, they're laying out the saw cut plan and they're kind of doing it in the field and they haven't really thought about the way this would look. So really make sure that you have a plan before you go out, and then we'll adjust it as we get into the field. Remember, concrete panels try to become square. They don't like to be other shapes. Concrete really wants to be as square as possible. Look for inlets, manholes, intersecting streets, the other side of the road, to make sure that your joints match up with what is happening in the environment and what the other limitations are of your joint layout. How are your joints going to be marked for the saw crew? How will the saw crew get water? I actually, at my church a few summers ago, we had a brand new front put out in decorative concrete, and the saw crew came to cut it, and they went to use the spigot on the front of our building, and they didn't know it, but the spigot on the front of the building actually doesn't work. The only one is around the back side of a 33,000 square foot building. So with that, they then had to go to Lowe's and buy a hose to be able to get the water from the back side of the building to the front side of the building, all while their saw crew is waiting. No one checked the spigot before they got there. So it cost them a couple hours, a little bit of frustration. So in that, you know, checking these things before you get started is kind of a benefit to you. Sawing of your longitudinal joints is just as critical as sawing of your transverse joints. Looks like we have a question. What are your thoughts on skewed transverse joints and construction concerns, performance concerns? We will talk about this as we continue to get into our jointing discussion, and then fully answer that as we go on. So I'm just going to leave that open and we'll continue on here. So the heat of hydration curve, many of you have probably seen this before. This is the heat that is generated by the reaction between the cement and the water. It's called hydration. And any cement-based products like concrete are going to go through a similar type curve, hydration curve here. So what happens is we mix our cement, water, and aggregate, and it's in the drum. Let's say we're using ready mix, and we mix it a little bit of time, 15 minutes or so, and the temp spikes, and then it actually comes down, and we place the concrete in this dormancy phase. Well, as soon as we are done placing our concrete, and as that concrete kind of begins to set up, the temperature begins to rise. So once we're done placing, we're kind of letting it sit there, and the temperature begins to rise, and we hit this peak of the temperature rise about 8 to 12 hours on a conventional day. We don't always have a whole lot of those in Michigan, but it's a good rule of thumb. So in that 8 to 12 hours, we want to check for our conventional sawing, or even right before that, check for early sawing. That window, once that temperature spikes and then it begins to decrease, we have to be aware that once the concrete heats up and then it begins to cool off. Well, as soon as it begins to cool off and we hit that 12, 14, 16 hours, that concrete is now shrinking. So as it heats up, it expands, and as it cools off, it shrinks. And what happens when it cools off and shrinks? We get our cracks to form. So we want to get our joints in our concrete pavements prior to this window here.
Heather, we've got a question.
We've
got a couple of questions.
I didn't know.
Let me.
I didn't know if we wanted to that one as we went.
Well, this one, your previous slide talks about wanting to keep the concrete square, and
yes,
then the question is, what about skewed transverse joints? And we've got a couple of agencies in Michigan which still prefer that as their option of well, not obtaining load transfer, but extending the amount of time before roughness comes into play and faulting occurs due to heavy loads, because the skewed transverse joints, being on an angle, have it such that the truck tires aren't all hitting that joint at the exact same time. That axle, only half of that axle is really crossing the joint before then the other half. So skewed transverse joints have worked. What other agencies around the country and MDOT, which never really did it extensively, the skewed transverse joints have kind of fallen out of favor with a lot of different agencies. They've instead switched to the dowel bars to provide load transfer. So the issue with skewed joints as far as performance is they don't quite perform quite as well as doweled joints, but they are fairly close with obviously the less cost because you don't have the steel dowels in there. But for very high traffic roadways, you're going to need a more positive way of load transfer, such as the dowels. Another one is on steel mesh. And that was one of your early slides, how we don't promote it because the cost of it and the very limited, if any, benefit doesn't make sense. What MDOT has found in the past is when they have older pavements that they used to use steel mesh in, if it gets too close to the surface and they get delamination concerns, and or if they have if it's too close to the surface and then they want to diamond grind that project to obtain some smoothness, that mesh can sometimes interfere with that diamond grinding if it is too high in the slab. So that's another great question there. Another question we have is early sawing. Is that the same as the initial relief cut? And I believe that is on the slide that you had that on, what you mean by early sawing. However, that may not, I don't remember the slide, Heather, but it may be referring to the early entry saws versus the conventional saws. There we go.
It's actually early entry saws. Those are the wet saws. So we get on the pavement a little bit earlier than a traditional
traditional wet saws. Okay.
And then we have saw cut timing may be different to capture unless there's a maturity meter installed or the contractor is monitoring the concrete's internal temperature. Can we share our thoughts on this? Concrete isn't perfect. Yes, that's a great, those maturity meters are awesome and they're a great tool, but concrete is not super confusing. If you stick within that window, kind of look at your temperatures, I think we can do a pretty good job estimating at when these saw cut windows are. I think where we have a lot of our issues with saw cutting is that many contractors believe somewhere along the line that if you saw cut within 24 to 40, you're good. And the reality is that 24 to 48 hours, that's where we're having this issue. When people are really trying to saw within that window, that estimated window, maybe 8 to 12 hours or 6 to 10 hours, or using those early entry saw cuts. I don't know about you, Steve, but I don't see as many issues when we're doing that.
No, they most saw crews utilize the scratch test where they'll take a nail, a metal like form nail, and in their hand, and then scratch the surface of the slab to see how hard and if it's crusted over, and they'll typically do that to determine whether it's hard enough to saw. And that is fairly typical. Yes, maturity meters, maturity monitoring will help determine that temperature curve, like Heather is showing, the hydration curve, as well as correlate to a strength. But a good saw crew would typically know how soon they need to get on it, given a particular mix and a particular condition.
Okay, large areas of pavement to be saw cut timings become critical. Our thoughts, absolutely, especially depending on the thickness of your concrete. So you have to know the crew, you have to know how quickly they can produce. You need to pour accordingly. So making sure your pores aren't so big that you're having trouble getting on the saw cut timing. You might need to have more crews than what your have scheduled. Those are kind of dependent on your output and what you need to be able to achieve. So if you're doing a huge area and you have one saw crew doing it, you might need to change the way that you do things in order to accommodate that. Okay, we're going to continue on here a little bit and we'll keep trying to answer these questions as we go. So again, I just blew up the conventional sawing window here, and you can check for conventional sawing and again, the early entry saws, which we're seeing more and more of those early entry or wet saws. So the thing with sawing is if you saw too early, you get a lot of raveling. If you saw too late, you could get a lot of cracking. The sawing window kind of is this line between these two. We want to see a little bit of raveling, just a hair. We don't want to see pristine saw cut lines, because if you see something that's super pristine, there's a chance that they actually were on it late and that concrete is already set up. So that concrete could be cracked even when you see that pristine line. So it is good when Steve and I go out and we look at these things, that we see a little bit of raveling. That's not a bad thing. So again, the saw cut window varies with temperature, admixtures, humidity, weather. We need to be aware of how we're pouring in the effects of this on the saw cutting window and be prepared to make adjustments as necessary for optimal placement. One of the things when I'm talking to contractors is as they're planning out their pour days, some of the pours I'll hear, a lot of times it's more with residential guys, and they'll pour a driveway, 4 or 5 o'clock on a weekday, and then they'll come back pretty late. So they'll pour it in the summer, maybe a nice July day, they'll pour a driveway at 5 o'clock. Well, then they'll come back 5, 6 o'clock the next night, or even 2 days later, and go to cut that driveway, and that driveway's already cracked. Well, if you're pouring at 5 p.m. On a nice hot winter or summer day, it's winter, I'm looking out my window right now. On a nice hot summer day, that saw cut window is going to probably be closer to the 8 hours, which is you coming back pretty early in that morning. So again, being aware of when you're pouring, the temperature outside, and what your concrete is doing is important in determining that saw cut window. And to answer the question up there, we do want to be scientific with our saw cut windows, but there are tools that you can use, and they're expensive, and those are great tools, but their concrete is kind of predictable. We can do a good job of estimating these without all of these expensive tools. I'm not saying that you don't want to use them, but I'm saying if we are aware of the temperature, we're aware of what admixtures we're using, we're aware of what's happening around us when we're pouring, how we're pouring, the time of day, things like that, you can do a pretty good job of judging when your concrete needs to be cut. So again, the sawing window is the brief period of time during which joints can be sawed successfully. Begin your saw cuts after the concrete has hardened enough to permit sawing without raveling or moving your aggregates. Finish your saw cuts before random uncontrolled cracks take place. Conventional saws, there's generally a 6 to 12 hour window for when you commence sawing. And that's a pretty large window, guys, 6 to 12 hours. It may be shorter than that, but there's a decent sized window for our saw cutting in which we're not going to traditionally have issues. Early entry saws have been a great addition to the market. The window begins as soon as walking on the pavement is permitted, and generally within maybe 3 hours. So those early entry saws, again, I'm seeing more and more because you're not waiting for that window, that later window. With your conventional saws, you can get on the pavements a little earlier. To finish the sawing the joints before the window ends, it may be necessary to continue regardless of weather or daylight conditions. And important, if cracks develop ahead of a saw, stop sawing at that joint and later use crack saws to form a joint sealant reservoir along that crack line. Steve and I actually did this on a parking lot down in Jackson that we just looked at this fall again. It had cracked, they got on it a little late, and it cracked right down the middle of this long rectangular slab of concrete. They had quite a large pour, and it cracked right down the middle of it. And we actually routed out they ground out that crack, put a joint sealant in it, and it's a working, functioning joint. So you can do this. You just don't want to keep going. If the concrete cracks off the edge of your saw, just stop and try to move ahead and maybe continue on with your sawing. So we do have some rules of jointing that we like to put out there and just kind of keep them in your toolbox, things to do and things to not do. These are things that if you do them 99.99% of the time, you're going to have a good outcome. And if you avoid those bad things, limit our risk in having uncontrolled jointing. But things to do, we want to match existing joints or cracks. So if you're pouring two slabs next to each other, we want to do our best to line up the joints or cracks that are in the existing slab to the ones that are in the new slab. We want to place joints to meet our in-pavement structures. We want to place, let's say, holes or things like that. We want to meet them perpendicularly. And we'll talk a little bit more about this as we go into our jointing practice. We want to remember the max joint spacing. Max joint spacing is typically 2 times the thickness of the slab in feet. So for instance, if we're pouring a 4-inch slab, we really don't want to have slabs greater than 8 feet. So if we're pouring a 6-inch slab, we really don't want slabs greater than 12 feet. So our joints, we want to keep under that 2 times the thickness with a max of 15 feet, no matter what the thickness is. Place isolation joints where needed, where we're meeting in pavement structures, where you're meeting light posts, corners of buildings, things like that. And you can make field adjustments to the joint location. A lot of times we can plan something out in the office and get everything ready to go and have a great plan, but then we get into the field and that catch basin or that manhole might not be exactly where it was on our drawings. It might be 6 inches off. Well, don't just stick to your drawings, make the adjustment in the field to match what's happening in the field and be practical, make good decisions. It's okay to adjust the joint layout in the field a little bit to make sure that we don't have uncontrolled cracking. Things to avoid, slabs less than 1 foot. Typically when we have slabs less than 1 foot, you're gonna have some issues there. Slabs greater than 15 feet wide. Angles less than 60 degrees. Concrete doesn't like those acute angles. They typically, what happens is the points of those break off or we'll have cracks right down there. 90 degrees is really the best. And you can in your joints through curved or radius points or areas where we have a major change in what we're doing, or we have a structure that we need to meet in order to hit it perpendicularly. Do not create interior corners, L-shaped slabs. We don't want to see those because they're just going to break off. The L will become an I in another, it's just not going to work out. The concrete wants to be square. It does not want to be these crazy shapes. Odd shapes, keep them, again, keep the slab square or even pie shaped, but square is still the best. You would not believe the crazy joint layout Steve and I get across our desk to take a look at. I actually had one a few years ago that was all dashed. It was a dashed joint pattern. So it was kind of crazy. And none of the joints met each other. And it was almost like a series of dashes horizontally and vertically. And I had to call the architect and say, hey, you can't do this. This is just going to crack. You might as well just put one straight joint throughout these dash joints. And he's like, well, I want it to be aesthetic. And I'm like, well, you're going to have some bunch of saw cut joints with a bunch of cracks between them. So, we don't want to get too creative with our concrete slabs. There's a way that concrete wants to be, and when we try to do odd shapes or get really creative with our jointing patterns, it can hurt us in the long run.
Heather?
Want to point out just in our question and answer, slab thickness, polish in use, base stiffness, friction can also be factors to consider when sawing. So any talk about trying to load the initial saw cut to force the crack in that location?
Yeah, Minnesota has done some research on on that. They would take a loaded water truck, fully, the tank filled up, and they would try to force all those initial relief cuts, initial saw cuts, to crack. Because there's been research on, not always does every single joint crack where you expect, or right away. It sometimes takes time, and not all of them shrink the same amount, and the crack widths or joint widths can be all different at times. So they want to make it as uniform as possible. So there has been some research on that, like a fully loaded, I forget how many gallons, water truck driving over a slab that's like 6 hours old, 8 hours old, right after it has the saw cuts installed. Number one, early loading, zero damage. So there's a lot. That's a whole nother discussion about early opening to traffic. But that has been researched. So that's a good point being made there. Let's just run down some of these other questions while we got them here, Heather. Thoughts on
Go ahead. What are your thoughts?
on
Go ahead.
existing asphalt and new concrete interface in a parking lot? Okay, so where we're butting up to existing asphalt with a brand new concrete parking lot, one way or the other, in or out, but regardless, still best practice to be perpendicular to traffic. Yes. Oftentimes you may want to thicken up if there is no load transfer and you don't have load transfer to asphalt from concrete. You may want to thicken up that concrete slab by an inch or two, not drastically, immediately in a vertical transition, but maybe sloped, to get to that thickened area. There are a lot of different details out there on those thickened edge type of joints, but that's an option. But yes, perpendicular to traffic at the surface would be the best. There's no need to skew that. And I think that's it. Yeah. Everybody else is loving my Minnesota accent, eh? All right. I'll mute.
No. So joint spacing recommendations, I know I touched on these a little bit, but the max slab size, 2 times the thickness of inches into feet, or 24 times the thickness. A 15-foot absolute max. Smaller is better. 4 inch, 6 feet, 6 inch, 10 feet. What we noticed and have noticed over at least my time here is that, when you're doing a 4 inch parking lot and we cut it into 6 foot squares, we have much less cracking and many less issues than we do if we stick to 8. Smaller just seems to be better in all of these. I think the load transfer actually at those smaller joint spacings does quite well. So dog legs, this is what dog legs look like when you're coming into radiuses or, different curb transitions or even structures. We want to dog leg or take these angles into what we're doing. And we'll kind of show you that as we continue on here. But utilizing the dog legs, we don't see this utilized enough in some areas. So we want to make sure that, if you're having structures that you need to meet, and again, we'll show you some practical applications of this, but we want you to be able to adjust for those structures. So we're not just jointing a pattern because that's the way we're supposed to join. It's supposed to be 6 foot all the way across and all the way down. Doesn't matter what's there, but we really want to make those adjustments. So adjusting your joints for your fixtures. And Steve will get into this as he's going to go through our practice jointing. But what we want to do before we start jointing is define our catch basins, manholes, fixtures, edges of buildings, things that are inside our port area that may affect our joint pattern, that may affect that are going to control where we start jointing. Non-telescoping manholes require a box out or isolation to allow for vertical and horizontal slab movement. Consider using rounded box outs or placing fillets on the corners of square box outs to avoid crack-inducing corners. Telescoping manholes, we do see occasionally. They can be cast integrally within the concrete and do not necessarily require a box out because the 2-piece casting does not inhibit vertical movement and it's less likely to create cracks within the pavement. So when jointing is near a fixture, it's desirable to adjust the joint so it'll pass through the fixture or the box out structure surrounding the fixture. And this diagram shows several acceptable ways to dogleg or shift a joint to meet the fixture. Okay, so I'm going to go through this here just a little bit. So right here we have where they adjusted the joint to meet this structure right here. Again, the joint would have over here, the joint was supposed to be here, and they adjusted it to meet the corner of the inlet to provide that. This is a telescoping manhole, so they placed it roughly in the middle of the slab and did the best they could there, but it does not have any resistance with its moving. Here we have a box out, so we did our best to come into the corners of that box out perpendicularly, or you box out here with perimeter isolation joint. So we're going to continue on
Got
here.
a couple of questions here. Telescoping manhole is one that moves with the slab. It's not fixed to the precast concrete structure below it, the actual manhole vault itself. That casting that's on top of it that we're actually seeing is not physically attached and can actually be moved and adjusted. It's not as common in Michigan, that telescoping manhole. That we typically instead tell folks to make sure they have joints in both directions that intersect those manholes.
Go
ahead.
ahead. I was going to say, when you're repairing an intersection of 4 different slabs where each slab has spalled in the corner and you make a square patch, would you say it would be smart to at least score the lines through your patch?
That's similar to MDOT's longitudinal full depth centerline repair detail, where they do, I believe it's a 30-inch wide, minimum wide patch to be able to get drills down in the hole and drill tie bars into the existing slab. But they will go ahead and put that longitudinal joint right back through that longitudinal repair area, creating roughly a 15-inch, slab on either side of it. They don't put tie bars underneath that cut. They only put the tie bars into the existing on either side. But yes, they score that line back through that repair. So that would be a similar detail to what MDOT has, and we can provide that to folks that are interested.
And then we have, what's the best jointing practice to isolate round structures, specifically when replacing utility poles?
There's a
couple.
There's
one of that, Steve?
Yeah, there's a flexible foam expansion material that I'd recommend that you can find it in varying widths. I would not use this MDOT standard asphalt impregnated fiberboard, which is designed to remain fairly rigid and cannot go around round structures. So I would instead use a closed cell foam, and it comes in varying heights, or I guess depths of joint, thickness of slab, really. But I would use that and tack that around a structure prior to pouring the concrete back to isolate that structure from whatever concrete repair or slab that you're pouring up against it.
Yeah, we just want to make sure that whatever your foam is makes the full depth so that your concrete doesn't bond underneath that foam, because sometimes we see that in the field where they order a 6-inch, but really that one of the pieces of concrete is an 8-inch or a 10-inch, and you might have an issue with it bonding underneath that foam. Box out required rather than just expansion around the casting.
Yeah, we don't see a lot of box outs in Michigan. For whatever reason, we've gravitated towards jointing around to that structure and not boxing out. You go around the country and we have the details for it in this PowerPoint about the round box outs, the diamond shaped box outs, the square box outs, all these other options for folks. And I've seen photos of them from around the country. But in Michigan, instead, we just typically pave right up through that manhole area. If you're slip forming, the finishers climb in the slab and pull that manhole casting up a little bit so it's level with the surface, and then either put concrete or bricks or something in underneath to level it out and make sure it's fully supported. And then the saw crew, hopefully makes sure to adjust their joints to hit those structures, those castings. Some agencies like the box outs, but it's not as common in concrete to box out those either ahead of time or gap them and fill them in after, as you'd see with other states and folks around the country. And then thank you, Andy from MDOT, for letting me know that they've actually eliminated that longitudinal joint in the new 30-inch wide longitudinal full depth center line repair detail. I haven't seen that detail yet, so apologize for not staying up to date on all of MDOT's special provisions and special details, but that longitudinal joint's been eliminated, but they have done it in the past.
Okay, so we have another one here. On my project last summer, we had issues with structures within our new concrete pavement cracking almost immediately after placement. The contractor tried every joint layout possible. Instead of using reinforcement around the structure, we isolated the structure with a sonnet tube and had 2 separate pours. On the second pour, the tube was removed and flexible foam was placed to isolate the structure itself. This seemed to work well and still no issues with cracking. Has the MCA heard of this?
I have not heard of that big of an issue. Yeah, there's 2 things. I mean, either your structures are in place and you're pouring up against them, near them, up to them, and then you have to make sure your saw cuts get in on time, because that structure now is your weakened plane. That's, a stress concentration area. If those of you engineers that understand that, from in your schooling in the past. And so you need to have, cracks or, joints that form cracks because they will occur, intersect that structure. Now, if you're pouring the slab first and you're gapping things out, it's the same thing. And if your joint layout is still not doing it for whatever reason, there's obviously a combination of factors that's causing that. And it's hard to say without having more detail, but that's a great way that you solve that, as far as taking those tubes to form out those gapped areas, whatever that is, and then definitely using the flexible foam isolation material before you put that structure in that area, because any place you have one of these structures, a penetration through the pavement, a gapped out area, that is a small gapped out area, I should say, that is an area of stress concentration that will cause shrinkage cracking to start at that place before it goes anywhere else. So you really need to pay attention to your jointing if it's not a continuous ribbon of concrete.
Okay, we will continue on here. It looks like we've got all the questions answered for right now. Keep asking them, guys. We want to make sure we can answer your questions. So developing a joint layout. We have a few things that if you go through this when you're doing your joint layout, and again, Steve will put this into practice in just a few minutes, but these are great kind of step 1, 2, 3, 4, 5, 6 to do this. So number 1, decide your maximum joint spacing based upon your slab thickness. Decide if you're pouring your slabs or your curbs first. Define all the lanes, entrance, exit drives, parking, and interior drives. Define all of your control points. This is the places where there has to be a joint or an intersection of joints. So this would be where all grade changes occur, high points, low points, different thicknesses of concrete, all structures, manholes, inlets, catch basins, buildings, light poles, et cetera, et cetera. We want to place our joints intersecting these structures. And we want to place our joints in line with the edges of islands, round versus square islands, and we'll show you this in just a second. Measure your distances and then add joints in both directions at equal spacing that's less than the maximum recommended. This is where you fill in the remaining part of the jointing plan. And we're going to show you an example of this as we move on here, 3 or 4 examples. And we want to define all of the areas that need expansion joints. Again, all fixed structures, pre-existing concrete, loading docks, foundations, walls, light fixtures, etc. Steps. We want to make sure that we know where all of these areas are so that we have put expansion prior to pouring. So with that, this short 6-step joint layout came from a combination of the recommendations from other organizations. But the reality is the common sense logic can be applied anywhere to anything. Remember that concrete wants to be square. We can predict where cracks will happen. And if you follow a step-by-step process and work through it for your joint layouts, you will have a good result. So let's practice. And with that, I'm going to let Steve take over the practice. And while he's switching this presentation over, a reminder is the MCA will help you with a lot of these things. So if you have a question on joint layout, we do this as part of our what we do here at the MCA, helping our members, member companies. Even if you're not a member company, I mean, reach out to us. We can help you maybe work through some of these things. Again, this can be, once you figure it out, you know, it gets easier and easier. But if you have questions, some of these projects can be really tricky. Roundabouts can be tough to do. We do a lot of roundabout joint layouts for our member companies to help make sure they do it right. So again, with that, Steve, I'll let you take over and we will go through some practice jointing plans.
Okay, I just noticed we missed one in the chat. The advantages of early sawing. Obviously, to get on the slab earlier, not too early that the saw sinks into the fresh concrete. Obviously, that would be too early. But to get on it earlier in that window, you have a better chance of those shrinkage cracks that are naturally going to happen, better chance of them occurring at those joints. So that's why early entry saws were developed, lighter weight, using skid plates to hold the aggregates in place as the saw blade is cutting through. They generally don't need to cut as deep, but they can. There are different models that can cut to the conventional depth. But the earlier you get on, the better chance you have of controlling any of that cracking. Because the old practice of waiting 24 hours and coming on it the next day to saw joints, chances are there's going to be uncontrolled cracks that have already occurred, whether you see them or not. So that's an example of late sawing, which nobody wants to see. So I just wanted to address that one. Follow up to it. Do you see early sawing in Michigan? Yes, we do. A lot of paving and flatwork contractors have these early entry saws. One brand is called Soft Cut. There are other brands out there. But that's kind of what some people will say in general for this early entry sawing. We do see it. Specs do allow it, and it typically has worked well. I mean, everything needs to be working properly as far as the equipment and that setup and maintenance of it. But we do not see a lot of negatives to it that at least have been proved. So a combination of early entry saws or conventional saws typically is used on a lot of projects. As far as depth of cut, like I did address it real quickly, it doesn't need to be as deep, except if the specs require that initial cut have a minimum depth to it. So most transverse joints are T/4, thickness of the slab divided by 4. Most longitudinal joints are thickness divided by 3, 1/3 of that thickness or depth of slab. And so if the specs do require that, then that, whether it's early entry or conventional, needs to be at that depth. If on a residential or commercial or I'd say non-public works type of job where the specifications rely on industry standards, industry codes, then in a lot of cases, just that 1 to 1.5 inch cut typically works, especially based on the thinness of a lot of those slabs that are placed. So let's talk about practicing. Let's go through some of these examples. First is an intersection. This intersection has a couple of right turn lanes. You can see this right turn lane over here because it doesn't line up with the curb over there, obviously, and then as well as a taper to a right turn area over here. What we recommend is, this is still in metric, I love it. These are taken from some old slides from ACPA. About 1 to 3 feet from certain areas, you offset a construction line in CAD. And we recommend that around all of your curb returns or circumference, your arcs at the corners here, as well as any beginning of a taper where you're adding a lane there. And this is, again, just a construction line and offset so that we don't want joints to go through these areas, because that's areas then where we'll have acute angles, triangular shaped slabs, cracking if we just continue our regular joint pattern through those areas. Next, we take our lanes, obviously very easily on a roadway. We'll have a parking lot example in just a minute, but on a roadway, we know where our lane lines are, pavement marking level. You can bring that up and kind of use that to make your joints. I personally, this is the 10-step method. I personally like our 6-step method because I bring up the level for your structures at this point, your manholes, drainage inlets. Water valve boxes are a little smaller, so that's not as critical. They have a little more flex to them, although if you can adjust your joint layout to hit the smaller water valve covers, then that's a great idea as well. So I like to bring that up at this point. Now this is where we violate the rule we just talked about, and that is where we are going to extend our joints through these areas where we have these offsets. And the reason for this is that we can then allow a slip form paver to come through and slip form these 3 lanes, whether it's 1, 2, or 3 lanes wide at a time, depending on equipment and availability, for the contractor. So these are areas then we don't have to put a little block out and that slip form, side form on the machine can just continue right through. This again assumes that we're going to slip form the slabs first, which is typically the preference with slip form pavers. It works much better to do the slabs first. That is the more critical item. That's what we want to get our ride quality and smoothness on. And then we put the curb on after that, just to help carry the water where it needs to go. And I'll show how to address that so we don't have acute angles in a minute. Next step is to put joints in, transverse joints now, wherever we have width changes. So the start and end of a taper, or the start or end of a tangent point where our curb return, our radius return at the intersection is beginning or ending. A lot of times in Michigan, it's kind of the practice to also make this an expansion joint at these curb return. Well, one of these two, if they're offset from each other. We'll talk about that in a little bit. But at least we know we need a joint there. And then after that, we measure in between those transverse joints that we've already started away from the intersection area to see what our maximum joint spacing is and whether or not we need a joint in those areas. So between our fixed points, we know we need 2 slabs here based on this distance. So we'll put 1 joint in. And let's say our maximum joint spacing in this example is 14 feet. Those may be 2 13-foot slabs. They may be 2 12-foot slabs, 2 12.8-foot slabs, whatever it is. And so the issue there is just divide it equally. Don't do your standard joint spacing, 14, 14, 14, and then you're left with a tiny little 4-foot slab, before the next spot where you need a joint. Or this whole thing that we're talking about is just don't take a 14-foot spacing and apply it over the whole intersection, over the whole project. You really need to think about start where locations that joints need to be, and then go in between those, not exceeding your 14-foot maximum joint spacing if that is based on the thickness of your slab, what you're going to be using.
Steve, it says, are we still using expansion joints?
We are still using expansion joints as isolation joints to isolate one east-west pavement from a north-south pavement, or to isolate the bulk of the parking lot from the entrance drive, or to isolate, the 10-inch loading dock from the 6-inch, parking area that butts up against it. Yes. Are we using expansion joints at regular spacings within concrete? No. So any of you designers out there that are doing not necessarily pavements, because we have a good handle on that, but I still see it in a lot of other specs for sidewalks, parking lots, alleyways, all these other different concrete projects where you'd be doing some flat work, and they still want to use expansion joints every 50 feet, every 100 feet, every 200 feet. And the answer to that is no, that's not necessary. Expansion joints are typically overused and over specified in those locations, and then they're typically not done right, and they cause more problems than they're actually worth. And you go through the analysis of the shrinkage that a concrete slab undergoes, the reasons why we put joints in, right, are because of shrinkage, and then the future expansion that it will ever see through its lifetime. There's formulas for that. Change in length of a slab is based on temperature, coefficient of thermal expansion, and all these other things. The expansion that occurs is not going to be greater than the initial shrinkage that has occurred unless you've got extreme temperatures, cold curing temperatures versus hot, actual summertime temperatures, or some very weird coefficient of thermal expansion of your aggregates, some weird aggregates that we don't usually see in Michigan, or super, low shrinkage or shrinkage compensating concrete mix. So no, regular expansion joint use is not necessary. Moving on, where the roadways actually physically intersect in the middle, the lanes themselves, these slabs in this blue box, at least it looks blue on my screen, they're all lane width by lane width. So if you have a minor road that has 10 or 11 foot lanes versus your major road has 12 foot lanes, these are, let's say 10 by 12 slabs in the intersection. Okay, we just have a question. How difficult is it to adjust the transverse joint spacing with a slip form paver? It's not very difficult to adjust if you've already planned it out ahead of time. If you're using dowel baskets, that location has kind of been predetermined and hopefully painted on the grade, and the baskets being placed as you place concrete or prior to placing concrete. If you're using a dowel bar inserter, that can be adjusted fairly easy as long as they mark where the actual dowels are implanted so that the joint lines up with those dowels. But the joint pattern versus the slip form paver, the transverse joint pattern is not that affected by the slip form paver itself. Once our intersection box is in, we again measure back to our nearest joint, and if we exceed our maximum joint spacing, we may need to put some additional joints in, as pictured here. Again, not extending those through the area unless we did for slip form paving of our major roadway here to allow for that. So we've got areas where we have and areas where we haven't, because we've defined what our mainline slip form lanes potentially would be. And we'll show how to account for that right now. So these are those types of dog legs you might see where the joints, in this case, at a radius, they should always intersect the center of that arc. So those of you experienced with CAD can understand that. You can snap perpendicular at that radius, or you can extend it through the center of that arc. However you want to do that in CAD. Those of you in the field would have to eyeball it or find out and have the surveyors put the stake where the center is if you wanted to get super technical. But usually eyeballing it, once you get good at it, is typically what folks do. To allow for that slip form paving, we adjust our curb and gutter profile, and that gutter pan extends out to absorb that little triangular sliver that would have occurred in these two locations marked as detail A. We also combine our transverse and or longitudinal joints at this intersection box area where we get close, and then go through the arc, or go snap perpendicular to that arc. This little section of joint here would be undoweled and untied. MDOT would denote that as a W joint, a plane of weakness joint, which has a pay item associated with it, but is simply just a saw cut with no lane tie steel or no dowel bar in that location. Dowel bars have to be along transverse joints. They have to be perpendicular to the center line of the roadway. And then lane ties, I guess, could potentially be used, but that joint acting sort of as both a longitudinal and transverse joint should not have any steel in it, so that it can open and close and we don't lock it up with any steel in that area. At this taper area, we do similar to A in that we bump out the curb and gutter profile so that that gutter pan absorbs that little triangular chunk, and we don't have a constant curb and gutter profile. Again, slip forming first, putting curb on after. You just put the back of curb form in after the lane is in, and you just fill in those areas with concrete. And it's whether you pay for additional lineal footage of curb and gutter or what, that's up to folks in the field to determine how that is paid. Or if you try to measure the triangular chunk separately, and even though it's placed with the curb and gutter, pay for it as pavement versus curb and gutter. Other options you'd see, You can adjust joints in the field, typically a foot or two if needed to meet the edge of an inlet. We do like to see adjusting and dog-legging joints to meet structures. And if you do a box out, and in this example, a square box out, you know that you're making that L-shaped slab. A crack will want to form off the corner of that box out, and you're going to want to put steel in there to hold that crack tight. Oh, by the way, let me back up. We do show expansion joints here at the one of the two curb return tangent points here, the furthest one back here. So that would be your expansion E2, typically a doweled expansion joint. All right, we've got a comment here. In Washtenaw County, they've got a concrete pavement on Wagner Road that has experienced some cracking outside of the saw cut joints. Keeping the joints, both those sawed and tooled, sealed has prevented deterioration of the pavement. Okay, so that's a good point. Uncontrolled cracking still sometimes occurs. And the best thing to do is, especially if it occurs later on and not within the acceptance or warranty window, if you do have a warranty, best thing to do is just seal those joints, seal those cracks, since they're now acting as joints, to help keep water out and minimize any potential spalling from incompressibles getting into that joint. Okay, let's look at a small parking lot in this example. So I just picked this off of Google Maps since it kind of fit what I wanted to do. And here we go. Let's say we convert that asphalt to concrete in this example. We've got 3 catch basins, everything sloped to the middle in the typical parking lot design like we see here. The edges are high and everything slopes to the middle for our 3 catch basins in these locations. What do we do? Let's assume it's a 4-inch concrete parking lot. We're going to go with an 8-foot max joint spacing in this example. It's only cars, there's no heavy truck traffic coming into this small office building. So 4 inches should suffice. Some engineers might want to go with 5 just to be safe, to feel a little more comfortable with that. First off, I'm going to define our drive here, and I'm going to delineate or separate the parking area from the drive, parking area from this little section of drive, and this little section of drive from here. So that's how I would lay out the joints in this parking lot example. Again, you want to dog leg them when they get to the edge so you don't have any tiny little slivers and triangular chunks. Next, I would put joints in line with those structures. So a transverse joint in line with each of these structures here, as well as longitudinal joints that line up with those structures as well, kind of starting to form some lanes. Although when you measure, you can see we're probably about 16 feet or so in this drive approach here. Therefore, we're going to need some additional longitudinal joints to stay closer to our 8-foot max spacing, which is what we would recommend for a 4-inch slab. Same thing with this. Once we've got joints in line, measure those distance. All right, maybe these are a little more than 8. Maybe they're a little less than 8. I don't know what the scale is here. Again, it was just drawn off a Google map to get started. And then we measure in between and check between our fixed points that we had originally. And here we can get by with 4 joints at some spacing that's hopefully less than 8 feet. And that's pretty simple parking lot joint method. Roundabouts are probably one of the types that we get most involved with agencies, cities, counties, and MDOT in some cases, because you get to a roundabout, it's a different shaped intersection. Maybe people don't have experience with it and they think, oh, concrete's not going to work because there's too many joints. Well, there's a lot of different options for you. We'll go through them here. The key is to develop a joining plan, whether it is done in CAD by the engineer, which you're probably going to have to do anyways to come up with quantities of your CP, dowel joints anyways. So you're going to have a test plan probably developed in CAD anyways. So you might as well just publish it. And if the contractor wants to make adjustments, they can propose a different plan. So number 1, isolation joints, expansion joints. Just like in a regular intersection, you do want some accommodation for that expansion or difference in joint patterns that can occur. 2 main options here: isolating the circle from the legs at some point. or doing the pinwheel option and moving your isolation joints out to essentially beyond the splitter islands. And most agencies have gravitated to the pinwheel option because they like it. So here's the isolating the actual circle from the legs. You can see the slightly thicker expansion joint would be this circular one here. Depending on your maintenance of traffic pattern, if you're building it under traffic, this may not be possible. You may need to put the isolation joints either out at the splitter islands or within the roundabout itself. Here is a pave through option, where you would essentially assume that the north-south roadway here is our main roadway. Most people are driving north and south and not turning. So this has not been used much that I've seen, because most roundabouts are being put in at intersections where we have a lot of turning traffic, especially opposing left turns and lots of people, making turns, T intersections, things like that. So we haven't seen this one as popular. Here's a 2-lane pinwheel method. The reason we call it the pinwheel is once you're in the middle, the circle, the longitudinal joint directs you out on the next leg. So once you're in, this one's directing you out. Once you're in here, it's directing you. In this case, this was a private development on the west side in this intersection, private drive essentially. Not a lot of traffic coming in and out of here. It was mostly more of a T intersection as far as the amount of traffic that utilized this roundabout. So they decided to carry that one all the way through to the south. And this one was a single lane going into this intersection on the east. So what this one has been built, for those of you from the East Lansing Township area, this is Sam's Way and Wood Street. It's going to undergo some a little bit of work this year due to some different traffic patterns that have developed. But at any rate, this is your 2-lane pinwheel option. A 3-lane directional pinwheel option. This is a more true pinwheel where the longitudinal joints do direct you out of the roundabout. Folks that are concerned about, well, what if I don't want to be directed out of the roundabout? The next longitudinal joint picks right back up. So this driver, if they're coming in from the east and going to go south, they are in the roundabout and they know they're going to go south. So then their eyes can pick up these longitudinal joints as they come around and then focus on these longitudinal joints, moving them out. And this typically lines up with a lot of pavement markings that the designers will come up with. So again, that's my recommendation, which is what I did with this one. You can see the pavement markings brought up behind it. And I tried to draw the joints to line up with those pavement markings as best as possible. Here's how that one would be looking at in a pour sequence, perhaps, which each different color is a pour sequence that you could do on a particular day, with perhaps the green being done first, then the 2 yellow pinwheel portions, then the 2 orange ones, and then the pink all in one day, jumping around to do that. So here's an example of that widened gutter that you might see. Again, standard curb and gutter profile here with your typical widths, but then we don't want these triangular slivers. We want to pour them either with the slab or with the curb and gutter. We don't want it separately because those little skinny acute angles will definitely crack. And we would rather have them cast monolithically with the curb and gutter or with the slab itself. So here's an example of some of those box outs that we've seen. I think this is from Canada, from Ontario, I believe. They like the round one. I've seen this for some asphalt roads around different agencies around the state that they want to protect their castings with a box out. But we haven't seen this in concrete as much in Michigan recently. Fairly common in Michigan is simply to joint the concrete through an inner line intersecting with the structure. Both longitudinal and transverse if possible, but if at least one, if not the other. We also do want to see a joint coming off of one of the 2 corners of the castings, because we know that is an area where we will see cracking as well. Okay, we have a question here on using expansion joints for isolation. Expansion allows for less restrained movement that will open up the adjacent contraction joints, yes, reducing the load transfer at those joints. Correct. Would it function better as a simple 1/4 inch isolation material in the joint? Yes. In general, the issue with MDOT's standard expansion paper historically was 1 inch. I believe they still have that as an option. I don't know if they have the 1/2 inch option, but that fairly thick asphalt impregnated fiberboard can close up significantly over time, which means that all the joints beyond that, away from that expansion joint in both directions, are now opening up. And like is mentioned in the question or in the comment. So if we provide for less expansion in that original expansion joint, we'd probably have less opening up. So I would like to see some discussion with MDOT standards folks on different expansion joint details in the future. So that's a great question on that. I personally like that 1/2 inch foam expansion material that you'll see on commercial jobs, parking lots, residential, that type of thing, up against building where a sidewalk goes into a building. Sometimes you'll see that foam expansion paper, typically often without even any joint sealant material over top because it doesn't degrade as much. I like that one and at the closed cell where it doesn't soak up any water. That's one that I'd like to see added to the MDOT details. So we could talk about that with MDOT folks in the future. So let's get into some things about what happened. Reminder of when sawing should be occurring, whether it's the early entry saws or the conventional heavier wet saws. What happened? The one on the left here, you can see obviously our saw cuts did not control this cracking. This one was, I believe, some cool weather and a slow setting concrete mix that had some high amounts of slag cement being used that with that cold weather caused that concrete to not set up in time. So the saw crew had to wait longer. Meanwhile, that shrinkage was still starting to occur. So this is an issue of a cold front and a mix that works well in hot weather, but needs a little more attention to detail in cooler weather. Similar to this one on the right, the exact same thing was happening. Saw crew was waiting and waiting and waiting, finally got on and did saw the joints, had a little bit of raveling. So they were early in the window, but same thing, high amounts of supplementary cementitious materials that slowed this concrete set in very cool weather. This was, I believe, a November or December placement of a thinner concrete slab. You can see the smaller joint spacing here. And then not a lot of mass there to have that concrete really kick off that hydration reaction. So it sat there for a bit. So in both of these cases, what could have helped would be, at the very least, some plastic to cover it up to hold a little bit of heat in, blankets if it's really cold below freezing, changing the mix design slightly if possible, if allowed by spec or by mix design, to reduce some supplementary cementitious materials, using hot water instead of the standard, cold water, well water, or municipal water supply. So there's a lot of different ways to hopefully counteract that. Here's one where they were way too early in the window and that saw caused that raveling. Instead of cutting through the concrete, the saw blade ripped the aggregates out of that freshly placed slab. So too early in the window. Again, same type of things could have been done that we just talked about. Here's one, integral curb and gutter. A lot of agencies around the state love this. I like it as a pavement design engineer because it gives you that nice thick 6 by 6 inch beam that's added to the edge of your pavement. Really helps with edge loading, reduce the stresses in that area. However, a standard saw or even those soft cut saws can't climb up the vertical face of that curb and on the top of that curb to cut that. So it's a second step operation to finish that saw cut. And it's typically a handheld cutoff saw. So that second step was not placed in time. You'd need another crew member with that cutoff saw walking right behind the walk behind saws and those operators to finish those cuts and not rely on that same operator to stop, drop back with that other tool and finish that cut. Here's another example why we don't like those joints just to continue straight regardless of where they are in space. You need to stop, prevent those little slivers, those triangular chunks, and instead do something like this, which is don't even continue that cut, stop it, and go perpendicular to that edge at that area. I know that he was probably wanting to line it up with that expansion paper that had been placed in that curb. This again is the MDOT standard, the 1 inch thick. Here we see the flexible foam, the 1/2 inch thick, which I really like instead of that thicker, rigid stuff. Speaking of the 1/2-inch foam, here's one we would need around these light pole bases in this parking lot. And this is an issue where, yeah, we have this cracking that occurred. However, you know, your saw just can't get to the edge. You don't have a zero clearance, you know, saw with no guard or anything on the front, typically, in most cases, unless it's an unsafe condition. That's not a bad thing. The fact that the crack actually occurred at the joint is great. And the fact that it is in line with our joint, and our joints are in line with our structures, this looks perfect to me. I don't see an option with this. If this is a concern, because obviously the light pole bases were placed first and the vertical obstruction was there, you could go in with some joint sealant material and fill up that crack if you're worried about it spalling. Here's one where we've got probably angled parking spaces. At the very least, we've got an angled saw cut at this handicap zero clearance, parking space here, and the two didn't line up. Whether this walkway area was placed first and the actual parking space was placed second or what, I don't know. But we can see our saw cuts did work, except where we want things to line up. All saw cuts should line up. So, and just redrawing that, what should have happened is something like this, okay? We stop that cut back there and dogleg it, which just means we change its direction. And the operator stops, picks up the saw, remaneuvers it, drops the blade, and continues on in line with this other cut. That's what we would rather have seen. Here's one where we've got two different placements. You can see the different colors. We've got our expansion material. Whether it's necessary or not, I can't say based on seeing the whole big picture, but that's good that it's in there, I guess. But we've got a few extra cuts here and some triangular slivers. Probably didn't need to happen. What would we have done in this case? Well, this is what I would have recommended to be done. Take the two saw cuts, where they meet, stop them, combine them into one, and go perpendicular to the edge. So that cut and that cut would not be in there. We'd stop them, combine them into one. We do have this little slab here yet. So there's another, and I would have possibly not even done these two cuts where they had occurred, possibly moved this cut over slightly and handled it even different than what we picture here. But a minor change right there would have hopefully solved any problems, as well as some major changes would have been nice too. Here's one, casting drainage inlet, round inlet here, just didn't finish the saw cut on this side. We want to see those saw cuts. So that's going to crack on its own and potentially spall a little bit. Here's another one, again in a parking lot, where they did form that dog leg, which is great. But then this one, I like that saw cut going in there off of that corner. But then these two combine, and then they never finished the cut to the corner. So I would have probably just, instead of this little piece of slab there, cast it with this one, as long as our overall distance to the next joint isn't greater than our maximum joint spacing, and then dogleg that cut perpendicular. Here's one. This is actually that parking lot in Jackson that Heather mentioned, where they didn't do any cuts and came back the next morning, and this crack had been in there at the weakest point, which was the narrowest point in between the island and a walkway on the other side. And so essentially was that initial relief cut was actually a crack. They came in and then epoxied that one. And then the rest of the saw cuts were placed in the next phase at a proper time. They also had two different pours where they did a totally different joint layout. And I would not have done all of these triangular ones. You want, when they meet the edge, to go perpendicular to the edge. Here's one that we've recently looked at where the curb, not curb and gutter, just curb head, was placed separate. As a separate operation, was not a monolithic or integral curb and gutter.
Steve, I want to chime in on this one.
Yeah.
It was integral curb. It looks a little funny, but this was an integral curb that they decided to cut the parking lot. Okay.
Gotcha.
That makes sense. I know the lighting's a little off, but they poured the whole parking lot with integral curb, and they cut the curb at 8 spacing than the parking lot.
Yeah.
So every parking lot joint cracked the curb, rather than just cutting the curb with the parking lot, which is what they should have done.
Gotcha.
Sorry to interject there, but
No, it's all good. This is that same project, different
Yeah.
spacing, as Heather mentioned, in the curb than the parking lot slab itself. So there's another example of like a little closer, but still not the same thing. The concrete slab is going to dominate this little piece of curb, and it's going to crack all the way through. This cut is not causing anything to happen at that location. Here's one where they didn't dog leg. I like to go back a foot or two, maybe 3 foot, stop that standard joint, in its normal straight location, and dog leg into that casting. Just if you're a saw guy, look at that center right there, that casting, and wherever you start, point the saw right at the center. If you point it at the center, you'll be perpendicular at the edge. So this is something I would have rather see. The reason for that, I'll go back to what we originally or actually have, is that concrete has its arms around that casting. Okay, think of it that way. This piece of concrete on the right, and its arms are rigid, and in the cold weather, it's going to want to pull away from that casting, and those rigid arms are going to break off as they're wrapped around. And so anything that wraps around, it's going to crack anyways at this location as this slab wants to shrink and pull away from this joint during cold weather. So this prevents those arms from wrapping around and gives it a spot to pull away that's even. Same type of thing. We'd want to see some dog legs on either side, and these cuts not even occur, and that would be integral cast monolithic with these slabs. This one almost pretty much lines up with the center, so that one was good. Again, here's one that no joints lining up with this casting, so we would prefer to instead see some saw cuts. Yeah, see, this is one in a parking lot where this is your initial point of stress concentration that very first night when that concrete's still fresh, whether the cuts are in there or not. That joint needs to be in there because that's the first place where it's going to want to start pulling away as that massive ribbon of fresh concrete is undergoing its hardening and shrinkage and everything else. Here's some other details from some projects we've looked at in the past. One where we've got a nice transverse joint spacing, but they did a square block out or box out around this casting and then oversawed slightly into it. I feel that this is going to continue cracking. Now, this is fairly recently placed and hasn't cracked yet. Here's another one where they didn't intersect it with any joints. I worry about this cracking in both directions away from that casting. Here's one where again, they try to create some sort of a block out, but not with another joint in this direction around this casting. I would have rather moved this joint over, lined it up with this corner, and done away with this joint altogether. So like we see here in the photo, I would like this a lot better. Here's another one we've looked at with a 45-degree joint pattern. The issue with these is that we worry about these little chunks coming out, breaking out over time, as well as them not actually cracking the entire way. I would have rather liked to see this type of detail where the two combine and they go perpendicular to the edge where they meet the edge of slab there. So hopefully that makes sense. We feel it's common sense. If you see something that's not right in the plans or out in the field, just make sure you tell somebody. Stop the work and talk about it before the concrete cracks. So that's what we don't like to see cracks. I know a joint is still a crack, but I'd rather see a nice straight joint than a crack in our fresh concrete. One question here on raveling. I did show that massively raveled joint. That would probably require a repair. MDOT has a new procedure for spall repairs in new pavements in the new spec book that's coming out. That's available for those of you setting up projects that are going to be let in August or later. And theirs is, I believe it's 4 inches wide by 2 foot is an intermediate spall. You would patch that with a spall repair material after prepping that spall. But those were fully raveled across the entire length of joint. That would require a full depth repair at that joint. So that detail is slightly changed. They also, and small spalls, I believe less than 1 inch total width, or raveled joints in that case. If it were less than 1 inch, they could fill it with joint sealant material. But that one looked to be 1.5 inches or greater in width along the entire length of that joint. So that would not be allowed to be filled with joint sealant. You'd have to replace, do a repair. Okay, everybody's going to be getting it 1.5 hours today because of how long Heather and I went. And
we're so long-winded, Steve.
I know. I love to talk. I mean, just ask my wife and kids. But let me share this other one here to summarize. Let's see. Thank you.
Yeah, you're on the right one.
This one? All right. The
Yep, you're
video
good.
of today's webinar and the handouts, which I just created, by the way, while Heather was talking, will be uploaded to our website. Our awards are being highlighted on social media, so maybe some of you have seen that on Facebook, LinkedIn, Instagram, and Twitter.
Yes.
We've got another one.
Follow us
tomorrow. Sorry, we've got, another award being highlighted tomorrow. Those MCA members, companies that are on the call, and any employee of an MCA member company, our annual membership meeting is next Wednesday at 9:30. That webinar is available for sign up on this annual conference page. And we want to thank our sponsors again, these 3 companies' logos that we've seen on this screen. All right, I did mention the Minnesota research on joint activation. I'll follow up on that, and I will make sure that the PDF of this has that link in that PDF that we're going to upload of these slides to our website. Anything else, Heather?
I don't think so. I think we're good.
Okay. Thanks, everyone. Please feel free to reach out to us with any questions. Website should have our contact info if you don't have it. And we thank everyone for your attendance.
What's our next webinar, Steve? Tuesday at 10 a.m. And who are we having? Who's next Tuesday?
Yeah, I'm trying to, let me drag it over here. Floor moisture mitigation. We've got folks with Vapor Lock to talk about some additives we can use in our concrete mix to mitigate floor moisture for flooring materials, as well as to reduce steel delamination and rusting of steel in any reinforced concrete. So that'll be our next one.
Thank you.
And then we are scheduling all the way out through March 9 will be our last one that we currently have scheduled. So take a look at our schedule. We just added March 4 and March 9. Take a look at those and feel free to sign up. Enjoy the sunshine, everyone, and the nice cold weather.
Bye.